All right, we're going to solve this pattern. First of all, starting with the explicit formula. Okay, we'll start with a table. So looking at n is the figure number and f of n is the number of squares in it. So the first one obviously is just 1. The second one, we can count these two, 1, 2, 3, 4, 5, 6, 7, 8. Okay. The third one, now at this point, I'm not going to count these one by one, right? I'm gonna group them and start to do some calculation. Okay. So this is where I put my computation column in. All right. Now, for illustrative purposes, I'm actually going to do 4 first. Okay. So if I were asked to count all these dots, again, I'm not going to do it one by one, but I'm going to look at it and try and notice groups of them. Okay. So I notice this group looks like it's 4 by 4 minus 1. Like it looks like a square, and then I can just almost see this one, but it's not there. Okay, and then I also notice this is the same thing. Right? It's a square missing 1. And then I notice this guy here, I'll just add him in at the end. Okay? So, looking at this, I want to write like a computation expression to match this grouping. So the way I would calculate this is something you just do in your head, and now you just you just put this in math. Okay? So you say 4, this is 4 times 4 minus 1. Okay? And then there's 2 of them. Okay? So you multiply by 2. And then you add in this group of here. It's 1, 2, it's 4. Okay? And that gives us 16 minus 1 is 15. 15 times 2 is 30. Plus 4 is 34. Okay? So let's just kind of do that again for the third one. The third figure. We group it again. We've got 3 by 3 minus 1. Okay, 2 of those. And then this group of 3 here. Okay, so for 3, that gives us 3 times 3 minus 1. There's 2 of them, so we multiply that by 2. And then you add in the 3 at the end. Okay. With these, you should start to see a pattern here. Okay, we can kind of do it for this one as well. 2 times 2 minus 1. 2 times 2 minus 1, and then this little guy is 2 again. Times 2 plus the little one is 2. Okay, so before jumping to making a generalized with n, let's just test ourselves with doing a big number. Okay, we'll do 20. Okay, if I had to adapt this, what would the 20th one looks like? Well, for the fourth figure, it's 4 by 4. So I would say with the 20th figure, it's going to be 20 by 20, right? And it's still just going to have 1 missing there. There's going to be 2 of them in the 20th figure, okay? And then this bar, it's 4 in the 4th, it's 3 in the 3rd, so it's going to be 20 in the 20th one, okay? This leads you right into, for n, for any figure, 150, a million, it's going to be n times n minus 1 times 2 plus n. That little one's going to be n, right? Okay, so now let's simplify this a little bit. We've got n squared minus 1 times 2 plus n. All right, distribute 2n squared minus 2 plus n, and then in standard form, that comes out to 2n squared plus n minus 2. Okay? Let's see. Let's verify that. So let's verify that for 4. So 2 times 4 squared plus 4 minus 2. That's 2 times 16. 2 times 16 is 32. Plus 4, 36 minus 2. 32 plus 4 is 36. Minus 2 is 34. That works out. Okay?